everybody. Thank you so much for joining our session on unlocking new AI use cases with sharing. I'm Darshana, product manager on the Marketplace team here at Databricks, and super happy to co-present with David, CTO of Jon Snow Labs. So before we get started, how many of you are curious as to whether the name Jon Snow Labs was inspired by Game of Thrones? Anyone curious? Yeah? Okay, so stay tuned because David is going to share that name origin story later. We also have some free swag, so if you're here till the end, we'll hand that out as well. So here's our product safe harbor statement slide. David, feel free to sit until my session is done. Thanks. And here's our agenda for the session. We'll be talking about the importance of collaboration in the age of AI, and I'll share how the Databricks Data Intelligence Platform and our Lakehouse collaboration capabilities help with AI innovation. David will be sharing how Jon Snow Labs is using Databricks Marketplace and Delta sharing to break down data and AI silos. He'll talk about a cool customer case study, show us a demo, and then we'll wrap up with some takeaways. So Gen AI is taking the world by storm. I think all of us know that, and so is AI in general. Here are just some stats from some recent reports to highlight this. 91% of organizations with $1 billion plus in revenue are actively experimenting with or investing in Gen AI. 75% of CEOs say that companies that invest in Gen AI are much more competitive, right? So they're making more money, they are innovating more. And I think the last one is quite interesting. I can relate to it. There's a 40% increase in the performance of employees who leverage Gen AI on a day-to-day basis. Gen AI and AI in general is pervasive. The use cases transcend industries and users, right? User personas. From dynamic pricing in the retail space to predicting the outcome of patients in healthcare, there are so many different applications. And why? My 5-year-old son and my 86-year-old grandmom use AI on an everyday basis. They use Alexa to play music, set reminders. My son is even learning a new language using Alexa. And in order to build good quality AI applications, it's super important for organizations to invest in a robust, performant, end-to-end AI platform, right? And that's what we strive to do through the Databricks Data Intelligence Platform. There are 3 primary value adds that you get from our platform. The first is complete control. Whether you want to build an AI model from scratch, pre-train one from scratch, whether you want to leverage an existing open model and fine-tune it, or you want to use a third-party provider's proprietary model, you get to choose what you want to do, and we help you do that. And depending on which mode you choose, you also have full control over the model and the data. And we'll talk about this in a little bit. The second advantage is production quality. I think we've all heard of the example of the car company that built an LLM-based chatbot that did what? It recommended a competitor's product instead of their product because it wasn't trained sufficiently on the enterprise context of the organization it was built to serve, right? Through Databricks, you can leverage capabilities like RAG to enhance your LLMs, augment these LLMs with enterprise context, and you can use features like lineage monitoring to make sure that the applications that you build are higher quality and production ready. And the third important benefit is lower cost. Our Mosaic AI platform has been optimized for building LLMs, and we've used a combination of different techniques like tuned parallelism for increased compute utilization, and these techniques have proven to reduce cost of LLM development by up to 10x, not just LLM, in general AI development. So let's talk about collaboration and sharing. Collaboration is quintessential throughout this AI application lifecycle, right? From data acquisition, organizations are augmenting their enterprise data with external data, all the way down to being able to collaborate on model packages, notebooks, super important to break down these data and AI silos along the way to accelerate innovation. But data and AI asset sharing is complex and it's expensive. Why? For a couple of reasons. First, it's difficult to access good quality data for training, evaluation, fine-tuning. And we all know that a model is only as good as the data that it's trained on, right? The second challenge is in today's world, most sharing protocols enable sharing of just structured data. But in reality, what organizations need is the ability to share AI models, unstructured data, right? So this is a challenge. And the third one is related to control. Because most organizations aren't building their own AI models from scratch, they are often leveraging third-party provider services to help them build models on their behalf, fine-tune, train, even host models on their behalf. And the challenge is, in order to make this work, organizations need to share data with the third-party vendor, right? So the third-party vendor can fine-tune these models on your behalf, can host models on your behalf, and then you lose control in the process. So not all organizations are comfortable with that. So that's where the Databricks platform makes data and AI asset sharing easy. So firstly, we have Databricks Marketplace that enables organizations to discover high-quality data and AI assets. These are not just data sets, but these are also AI models and solutions that are prepackaged notebooks for popular use cases. Second, our collaboration on Databricks is powered by Delta Sharing, which is an open sharing protocol. It's a no copy, no replication protocol. And one of its advantages is it enables sharing of not just structured data, not just Delta tables. You can also share unstructured data in the form of arbitrary files. You can share images, video files, audio files, PDFs, libraries. You can also share AI models and notebooks, right? So all of these diverse asset types. And the third advantage is because our sharing enables sharing of entire model packages, when you collaborate with these third-party vendors, you can gain control depending on the vendor. You can bring models into your infrastructure and you don't need to send your data and model outside, and you have full control over all the assets associated with your AI application development. So let's put all this together with an example, right? So here's a hypothetical model provider, farm model. They're a provider in the agriculture space, and they build models for use cases such as crop monitoring and soil analysis. This provider distributes both open source as well as proprietary models. And as you can imagine, the mode in which they distribute these two types of models is different. For the open models, they are comfortable sharing the entire model packages along with the model weights. For the proprietary models, they want to protect their intellectual property, right? So they don't want their customer to have access to their secret sauce. What they do is they distribute API endpoints for their customers to use. Farm model wants to meet customers where they are. So they want to provide their customers with a good user experience and good privacy. And they have lots of customers who are on Databricks. So they want to provide these customers with a good experience on Databricks. And of course, they want to acquire more customers, spread awareness of their brand. So here's a hypothetical model consumer, Crop Yield AI. So they are an agricultural startup again, working in the AI space. And what they want to do is use satellite and drone images to monitor crop health, detect diseases, and assess yield potential. Because they're a small, scrappy startup, they have limited resources. So they don't want to build an AI model from scratch. Instead, they want to leverage a good open model as a baseline and build on top of that. The other thing is they're also very cost conscious, so they want to make sure that their development is as cost effective as possible. They also care a ton about the privacy of their customer data. So they work with agricultural farms and other companies, and they want to make sure that any data that's sent to them stays within their periphery. And Crop Yield AI uses Databricks as their end-to-end data development platform. So how does the provider and consumer collaborate with each other? How do they discover each other, right? So Farm Model is a marketplace provider on Databricks. And they distribute both their open source models as well as proprietary models through Marketplace. Open source models, fairly straightforward. They're able to package the entire model, including weights, and Delta share the same. For the proprietary models, they distribute what we call solutions accelerators. These are notebooks that can have API calls to a model service that is hosted by the provider. So that way, when they enable access to the solutions accelerator, customers are able to invoke their service without being able to gain access to the underlying model and its package. Another interesting thing, they are able to monetize these two types of models individually. So on Marketplace, they're able to distribute the open model free of cost. They make this instantly available. And the proprietary model, they're able to gate behind a request for access flow. And they're able to work with customers to make sure they sign a contract before they share the application with customers. So Crop Yield AI comes to Databricks Marketplace, discovers farm models, open source crop monitoring model, and acquires the model using delta sharing. Next, what happens? So what does our consumer, Crop Yield AI, do with the model? This model works out of box with Databricks' AI suite of capabilities. So they can use this model for real-time inference. They can use this model for batch processing. They can use the model as is, or they can even fine-tune the model if they want. And here, Crop Yield AI wants to fine-tune the model, and we'll talk about that in a bit. Also, Crop Yield AI gets UC for governance by default, so they can use all of UC's capabilities like lineage, lakehouse monitoring. They can govern who has access to what assets related to the model and the data. Remember we said that our consumer cares a ton about making sure that their private customer data stays in their periphery? They don't need to worry about that here because the model is now in their infrastructure under their control. They don't need to send any data belonging to their customers outside for the provider to fine-tune or host model on their behalf. Also, because they were able to bring in the model, a foundation model from scratch. They were able to bring in a model rather than developing a model from scratch. They were able to save time and cost when it comes to developing the model. Also, they are able to optimize by choosing the right infrastructure, choosing the right hyperscaler that provides them the best cost for GPUs. They are also able to avoid vendor fees because often third-party providers do charge a premium for hosting models on behalf of customers. So Crop Yield AI, as we said, also wants to fine-tune this model. And for this, they need additional satellite image data. So they go to Databricks Marketplace and they're able to discover a satellite image data provider. And they're able to acquire image data from this provider via delta sharing because delta sharing enables sharing of diverse asset types, including arbitrary files such as images. So that was a quick snapshot of how a provider and a consumer can collaborate using an open model as well as volumes, image-based data. And David, later in our talk, will talk about proprietary models and how John Snow Labs leverages Marketplace and delta sharing to distribute those with customers. So let's summarize the benefits of AI model and asset collaboration. These benefits tie back to the overall benefits of the Lakehouse platform for AI application development. So the first is lower cost, right? When you're able to bring in models into your infrastructure that exist instead of starting from scratch, you're saving time. You're not necessarily paying vendors premium fee for hosting models on your behalf, and you can also optimize infrastructure for the best cost. Second, you're able to build production quality AI applications because you've started with a good benchmark model, and then you can augment that AI model with all the capabilities we provide on Databricks to make it better quality. And third, you can bring models into your infrastructure and completely control the model as well as the data. So here are some examples of diverse asset types that are distributed through Databricks Marketplace. So John Snow Labs distributes data sets as well as AI models. We have providers like LiveRamp distributing solutions accelerators and providers like Shutterstock distributing volume-based data, in this case, images. So a quick rundown on Databricks Marketplace. We launched it as generally available at Data and AI Summit last year. And since then, we've seen tremendous growth in the number of listings as well as providers. And we're very excited to continue to grow this ecosystem. If you would like to see specific providers or products on Marketplace, definitely reach out to us and we'd be happy to help out. And with that, I will pass the baton over to David.
Hey everyone, can you hear me well? Great. So let's talk about how John Snow Labs puts everything that Ashana presented to good use. So what about Johnson Labs? It's a software company. It's most well known for building the Spark NLP library, which is a very widely used open source library for doing NLP at scale, language understanding at scale. Commercially, the company has always been focused in the healthcare and life science space. So basically, we have a handful of large healthcare organizations subsidizing a much bigger, free and open source ecosystem. And we serve the majority of the market, so large pharmaceuticals, academic medical centers, payers, a lot of software companies. Basically, there are quite a few people who need to understand unstructured medical text in different formats. And what we pride ourselves on is accuracy. And that's really our role in the ecosystem, is to get out of bed in the morning, read all the new papers, look at all the new models, all the new open source projects, every claim that someone makes that something is more accurate. We benchmark. Most things do not reproduce. Most of the things that reproduce do not generalize. But the few things that do, our job is to give you the healthcare-specific, production-grade version of that. And really, our one promise is that we'll keep you at the state of the art. This is Jon Snow. Who is familiar with this Jon Snow? Okay. So Jon Snow is an actual historical figure. He's considered the father of epidemiology. John here was the youngest of 8. He walked to London, where he learned medicine, and he became a very well-known physician. In 1854, he's very well known for playing a key role in stopping a cholera outbreak. Cholera is a horrible disease, which killed several hundred people in a few weeks in Soho in London. And it was a classic data sharing exercises. But what you did in 1854 is that you actually walked door to door in a cholera-infested neighborhood for 3 days. And what Jon Snow did, he built this map. It's a very famous map if you go to visualization classes. It's called the ghost map, because every dot is a ghost. He built a map of all the people who died. And he got to a conclusion that what was common to them was one water pump that they all shared. Okay, and a lot of it was just interviewing people. By the time, really, you had to walk door to door, because even you couldn't send people around. Most people didn't read and write, or agreed. But that was a big conclusion, and Dr. Snow petitioned to the city to take the pump out of service, and the cholera outbreak indeed subsided. In London, if you go, the pump is, they moved it about like 50 feet, but it's still there. It's a point of pilgrimage if you're into epidemiology, which some of us are. But the interesting thing here that was the finding that cholera was waterborne. That was not known at the time. That was 30 years before the microscope was invented. At that time, saying that there are little tiny creatures in the water that make you sick, it was about as credible as saying that the devil did it. Okay, there was no evidence to support either theory more than one than the other. And that's one of the things that made Jon Snow famous. And that's really what we call, when we say we want actionable insights, right? We want surprising insights from data analysis. This is really why the story is famous. It's one of the first examples of really using data in tangible way to improve public health. And with Jon Snow Labs, we're 200 years later, but with the same goal. So our goal is to help the 21st century Jon Snows, of which are quite a few of them, right? And today we're talking about clinical trial acceleration. We're talking about pharmacovigilance and patient safety. We're talking about automated clinical decision support. We're talking about real-world data and real-world evidence and data anonymization. And there's I think there's about 70 of these kind of public case studies and peer-reviewed papers on our website of different cases. But what we're here to talk about today is specifically the Databricks and the marketplace and how we use it. So the first thing we have on the marketplace, we have 2,400 expert curated medical data sets that are available via data sharing and fairly widely used within the Databricks community. So if you're looking, for example, for a list of all the licensed medical physicians in the US, including all their details, all the drugs approved by the FDA, all the drugs retracted by the FDA, pricing, utilization, medical devices, mortality statistics, birth statistics, all the medical terminologies, ontologies, all the active clinical trials, all the reported adverse events, all of the data sets are there. We have a whole team where all we do is we find the data, we update it regularly. Mostly we clean it. There are 3 levels of validation, right? So you have this kind of very clean, enriched, nice data set that you can just use. We package it into 128 different data packages, since some of them are related. And yeah, you're welcome to take a picture, but it's also on the website. You can just go to the Databricks Marketplace and type Johnson Labs, and this comes up. And you can even click more and read the description on each one. And you can even click another button and start using the datasets immediately, which is nice. Okay, you do this. The other thing we have on the data marketplace, and that's something fairly new, we also have AI models. So traditionally, the Johnson Labs language models are available as a Python library. Okay, so you have a library, you have the models, you install the library, say, within your Databricks, right, cluster, you run it there, and if you want to de-identify data, you write a job. You want to extract 2 more characteristics, social determinants of health, you write another job, it does that. But what some people want is, look, can you please just give me an endpoint? I don't want to configure my own pipeline and to choose my own embeddings. I don't want to manage, right, a job or manage a machine. I don't really want to do anything. Can you just, just give me an endpoint and I can do that? So now you have this capability. There are more than 60 tasks, medical and language understanding tasks that we have packaged. Things like summarization, de-identification. Actually, we'll walk through some examples very, very soon. And here's why we did it. So the first reason is, look, some people just want a fully managed API. Okay, which basically, I understand that you have more than 2,000 models, healthcare specific in Johnson Lab, that's great. Can you just give me, the out-of-the-box, most recommended, simplest thing that just does this? Okay, it's kind of this. I understand I'm losing on customization, I'm losing on tuning. It's good. Just like how do you recommend, for example, out-of-the-box to extract patient demographics? You click to deploy. It's all managed. It's somebody else's problem, specifically Databricks. If the server is down, right, you just have an an endpoint that you call. But if that's all we wanted, then we could just build an API endpoint. We didn't need Databricks, right? You can, all SaaS companies have an API, and you just put an API online, people use it. But the problem is that in healthcare, nobody wants that. Specifically, if you're in a healthcare organization, you cannot just start sending patient data to some company in the cloud. Okay, that's sometimes illegal, even if it is like just not something you want to do. You do not want to share data. You should not share data. It's mine. It's private. You don't do that. So what the Databricks Marketplace enables you to do is take a fully managed endpoint. It's all complete. It's baked, but it runs within your infrastructure. Okay, so when you deploy it, it creates an instance within your Databricks account, behind your firewall, within your VPC, within your security control. Everything runs there. That instance does not have access to the internet. You never send anything to Johnson Labs. You never send anything to any third party. Okay, in a sense, if your organization trusts Databricks, right, so if you went through that privacy and compliance thing, then you're done. Like you can just use everything on Marketplace. Okay, and that's really what makes it very powerful for something like Johnson Labs. It's like, look, our customers, they do not use SaaS in general, right? This is why we had the library so far, because you install the library wherever you want, you run it there. And now you can really have the best of both worlds. It's still within your environment. Nobody knows anything. It's your intellectual property. You never send your data, share your data, but you have this fully managed solution as well. Okay, and that's why this was very interesting to our customers and to us as well. So let's talk about one use case that's actually putting this to use. This is something that, I wish you'd never have to understand what this is. This is the clinical guidelines for oncology. Okay, so if one day you go to an organ and say, well, we found something in your stomach, in your stomach, in your lung, in your breast. There's a decision tree that's a clinical guideline. Basically summarizes, here's the best practices, here's the recommended evidence, what to do in each case. So basically, we found this thing. Sometimes what you need to do is just wait, come back in 6 months. Sometimes we have to operate right now. Sometimes we recommend, well, you should take this drug. Sometimes we should take it out and send it somewhere for sequencing. Something depends on really what you want. They explain to you when you choose. Okay, sometimes they want you to choose. Sometimes they say you really shouldn't choose this time. You need to be open. There's these decision trees. Okay, they depend on those factors: your lab results, who you are, your clinical background, and sometimes in this use case, this with a large academic medical center, you want to see if you can automate or semi-automate. Look at the patient. Look at how can you recommend what's the best next thing to do. Okay, the problem is specifically in oncology. Most of the data that you actually care about is not available in structured tables. Okay, so if they took a pathologist, like they took a little part of it, sent it to a lab, you get a pathology report. If they did a CT scan, you get a radiology report. if you actually were in the hospital, right, there'll be some discharge notes, soap notes, other lab reports. And specifically, something that one of the largest pharma companies did about 6 years ago now. They actually had people walk through those decision trees, found that there are actually 300 little questions that you have to choose within the tree, right? So this depends on, for example, okay, size of the tumor, okay, we need tumor size. When it was discovered, okay, 300 points. And so only about 40% are available at all in any tabular format. Okay, so oncology is one of those specialties where text is very big specifically, right? There are a few of those. So here are some of the things, some of the models that are cancer specific that we built that are used within the context of this use case. Okay, we need to extract information from pathology reports, radiology reports, lab reports, sequencing reports. So the first thing that you want to do is to be able to extract medical entities. Okay, it was called clinical entity recognition. As you can see, you want the model to automatically identify them, and you want the model to identify, in this case, cancer-specific entities. Tumor staging, tumor histology, chemotherapy cycles, chemotherapy dosage, pathology reports, pathology results, response to treatment, biomarker results, histological type, histological value, all the things that, as healthy people, you hope to never hear about. It's all there. Biomarkers are very, very big. So now we live in the era of precision medicine, where mostly what people want to do is they want to actually sequence your tumor to understand which drugs are more likely to be effective for it. That could save you a lot of life, quality life. The other thing that you need in addition to recognize the entities is understanding what we are saying about it, assertion status. So for example, patient is a 40-year-old black woman with breast cancer, okay? So there's breast cancer is the entity, but in this case, we know that it's present. Okay, she has it. Versus without breast cancer or with suspected breast cancer, we're not sure. Okay, so we need to know positive, negative, possible. She started smoking when she was 20 years old, but she quit several years ago. It is clinically relevant, but we have to know it's in the past. Okay, similarly, sometimes you have things about the future, right? Yeah, we're going to do a surgery, very massive surgery. We're going to remove this and change this and replug this. It's relevant, but we need to know it hasn't happened yet. And her mother died of breast cancer at age 55. Also, it is relevant, but you have to know it's about the mother. Okay, otherwise you're going to get tons of false positives about the patient. The next thing you need are relationships, semantic relationships. There's more than 100 of them that we've built. What you'd expect, if you give me a measurement, I want to know the unit, I want to know what this is actually measuring, I want to know directionality, what part of the lung, right, you have the issue, what part of the lung they take the CT scan of. A lot of relationships are very important about time. Okay, if I have a date, it's very easy to find the date. It's a regular expression, but what is the date of semantically? The diagnosis, the date of the test, is it a future date? Right, is the birthday of the patient? Right, that's often very important to understand, to decide what you want to do. So you need those semantic relationships. Another thing that you want is often you want to map those things to standard clinical codes, right? So in healthcare we have ICD-10-CM for diagnosis, ICD-10 PCS for procedures, LOINC for lab results, and DCORX for medications. There are about 15 of them that are in fairly regular use. And this is important because very often in healthcare you can call things the same thing by different names. Okay, sometimes you just have spelling mistakes, right? So you want to normalize things to a specific code. Then you can also group things. If I say, I want all the advanced breast cancer patients, it's not a single code, right? It's a collection of them, it's a group, so you want the grouping to work. And also, this is in German, so yes, we do have support for other languages. The other model that's super popular is the identification. The identification is a prerequisite to a lot of analytics and a lot of data science work. Okay, something that happened about 4 years ago is that we reached the point where automated de-identification of unstructured text is as accurate as manual identification, as people doing it. Okay, specifically, if you have one person doing identification, usually between 93 and 94% accuracy. If you have 4 eyes principle, so 2 people do it separately, if they disagree another third look at it, you can get to 96, 97%. Now we have modeled that on real world data, is get to 98, 99% accuracy. So you see here on the left, you have the original text. The first thing you have to do is you need to identify all the sensitive entities. And then either you mask them, or what you do very often, you obfuscate them. So you take John Doe, you replace it with a fake name, with Jack Daniels, You take dates and you shift the dates randomly. You take identifiers and you hash them. And of course, you have to do it consistently, right? So if you change Joe to Jack, please, every time they say Joe, should be Jack as well. When you pick a fake name, it should stick with the same gender. When you change the age, stay with the same age group, kind of you want to be clinically reasonable. So those are also, that's available to you out of the box now on the Databricks Marketplace, right? And if you want to do anything that revolves around a large body of patients, usually you need to combine these models together. I want to de-identify it, extract the entities, understand assertion status, find the right relationships, give me the end results. Okay, I want to know these patients, okay, who are the patients with this specific biomarker, right, at this specific stage and histology, right, who have not yet started, right, this treatment. They may be a good candidate for this new clinical trial. The other thing, as I mentioned, our job at Johnson Lab is to do this accurately, and kind of the third question, okay, you say you do this, like, okay, like, do you? You know, or really how well? And, you know, to what extent? And definitely just evaluation is often tricky. So really, I mean, I personally look at it in two different ways. First of all is this, you know, peer-reviewed papers on public, academic, competitive benchmarks. And those are just a few cases where we've established new state-of-the-art results and we publish the papers, and this is something we do regularly, right? So now we've done it on medical text-to-SQL, recently done it on just on the Open Medical LLM leaderboard, right? To look at you know, medical licensing exam, PubMed Q&A questions. So that's one thing, and it's very important that, you know, the code is public, the data is public. These are not benchmarks we invented, they're competitive ones. But that's really half the story. The other half of the story, and I'm sure you know this if you work with any data anywhere, basically, is that when you get to real-world data, it's always more different, messier, and has different challenges you do not expect. Healthcare specifically, that's something else. Every hospital has its own way of practicing medicine, right? So they actually do things differently. They definitely document things differently. So I think that the other, you know, this is one half of the equation. The other half that you want is definitely have the ability to look at you know, real world example, right? So okay, has this actually been used on, you know, like 1 billion documents for, you know, 500,000 patients, right, over a period of time in the real world, and has decent feedback. And, you know, if you have both, you know that you have something that's trustworthy. Yeah, these are some of the recent examples on. Yeah, we're able to achieve new state-of-the-art results, so beating your GPT-4, MedPalm2 on medical question answering, kind of medical knowledge. And in general, there are quite a few benchmarks. The way academic benchmarks work, they're super specific and super limited. If you have a model that only does well on one thing, it probably only does well on one thing. So in general, you want something that does well on the whole range of things. So what I'd like to do now is really just show a quick 2-minute demo on how you actually start using this in Databricks. So how this looks in practice. So let's see how this works. So you within your Databricks account. No, wait a minute. No, we don't get full screen. I'm sorry, not today. So you want to search clinical. You see our models come up. You can click one of them. You have the model card. You can click get instant access. Except the term, it gives you access to the model. This copies it within your Unity catalog, so everything goes within the same framework. Now what you need to do, you need to open this notebook. There's one Johnson Labs notebook you need to run. So you see, you import it into your own Databricks environment, okay? And then you run it. What this notebook does, first of all, you configure it with your Databricks account. You configure the Johnson Lab license key, okay? Because as I said, we don't have access to it, so you need to give us the license key. Otherwise, we just can't install it. We can't do anything. And then you run the notebook. What this does, it creates a new instance, installs Johnson Labs, configure the license, opens the endpoint, basically does everything for you. Okay, so all you need to do is, you know, you click around, you fill in the boxes at the top, you click run, it's done. Once you've done it, you've deployed an endpoint, and what you can see now is an example of actually using it. So here's sample text, and then you have the code here. There are two interesting things. First of all, you can see we wrote helpers. We have an actual function called deploy. It means, okay, we're done installing, actually deploy the endpoint. That's one. This actually creates an instance within your account. It has all the code, and the most recent model. Once you're done, you can actually run, right? You can actually query the endpoint. And then also it's a REST, so you can use any library that can make a REST API call. Or just a moment, I just want to stop and show that. Or to use, I mean, we wrote also, we have a Python kind of wrapper that makes this a nice one-liner. What you are seeing here, where I paused, Within Databricks, if you go to model serving, right, this is the screen you're seeing now. So you'll see the model, you see my DID endpoint for the identification. You're going to see latency, you're going to see throughput, you're going to see how many requests, right? So this is available to you here, and of course, you can see the endpoint itself. As you can see, you can run here the query. You have an example text. You click, you have nlp.query endpoint, which is the code here. Once you run it, it calls your endpoint, and it does that. Okay, so that's it. So you did not actually have to use a keyboard to do this. Okay, you find the model, you click it, you get the access. You find the notebook, you copy it to your notebook, you run it, and that's it. You have a live endpoint. It runs privately within your own environment. Okay, and it's, if it's air gap Databricks, it's air gap Databricks, and it's going to stay that way. You can use it, you can share it within your team. You manage it via Unity Catalog. Okay, so everything on Marketplace goes to Unity Catalog, so you can decide who from you. If you want, you can make it public. If not, you can say, no, only those 3 people are allowed to access it, right? And then you can manage it. So all goes within kind of the same Databricks compliance framework. So that's all what I wanted to cover. Here is the summary. Really, the main points is, it works. It's in production. It's right there. You can use it now. It works pretty well. I've tried it myself a few times. What you get, really, the difference from really just anything that gives you an API endpoint is the fact that everything is within your own control. So from a compliance perspective, from intellectual property perspective, in case of wondering who's sharing your data perspective, there are no concerns here. Okay, you can run this basically off the internet. And specifically, if you are in the healthcare space, you have, it's now, I think we are 65, 70 medical language models that we maintain. Okay, and really, as I said, our one promise, we will keep you the state of the art, so accuracy keeps improving, the models themselves are updated regularly, right, as terminologies, ontologies get updated, and that's available to you to use. I thank you for your time, and good luck.